Okay.
Okay, so I just started the recording. Let me share my screen. Okay, so yeah, I think this is where we left last time. So we were trying to build the Docker image. So if you remember, so let me recollect myself. Yeah, so what we are trying to do. So we have package.json. Actually, let's go to test. So we have test.js code, and we have package.json. We have um, some dependency, right? So we have only one dependency, which is actually not used, but just to test this npm install and all these things. So we have one dependency. So this is our code, right? So test.js is our code. Then we have package.json, which tells us what are all the dependencies the application needs, right? Then we have a Docker file. So this is what we were discussing. So we are trying to create a Docker image um, which runs the which actually packages our application code and runs the application and should be able to run the application. So let's now build this. So last time we faced an issue. Actually, if you remember, it was taking long time for Docker build. You remember?
Yes.
Yeah. So the problem is, so when we actually say Docker build, so what it will do, what Docker will do is, so Docker will basically send all the files which is there in the current directory to Docker Daemon. So Docker Daemon is nothing but a process. So basically we have um, yeah. So if you see, we have this Docker process running, right? So basically Docker will be running as a process.
Okay.
So when I say Docker PS, it lists me all the Docker containers running. Currently, we don't have anything. When I say Docker images, it will list all the Docker images which is there in the which is there in my laptop. So when we execute this command, basically what it will do is it will when I execute Docker images, it will connect to Docker daemon. So Docker daemon knows how to reply to this command Docker images or Docker PS. Then basically whatever command we are executing, so it will connect to Docker daemon and get the data. Then it will display to the user. So that's what it's doing. So for whatever command we are executing, we need to have Docker daemon running. So if we have any issues with that, then Docker commands will not work. So for example, this is my Docker desktop. Um, so this is basically it's running. It says Docker desktop is running. So we have Docker running. So yeah, so when we say Docker build, it will send all the files in the current directory to Docker daemon. So that day what we had is we had a directory called node modules, if you remember. So when we say npm install, it will download all the dependencies from package.json, all the dependencies specified in the package.json, and it will download to the node modules directory. So the node modules directory was somewhere around 500 plus MB. So that's why it was trying to send all the files to Docker daemon. That's why it took time. So now I removed that. So let's try now Docker build. So I don't know what name we give. Let me just try to fetch the command. Okay, somehow I don't have the command. So let me just build a Docker build current directory -t React.js practice. So now you can see, so it is executing step 1, right? So let me open a new tab. So you can ignore all this. This is I'm just opening a new tab. So React.js practice. Inside this, I have Docker template. So here I have step 1, step 2. Step 1 is pulling the Node.js Docker image, right? So here you can see, so it did not take much time because I already have the image in my laptop. So it doesn't need to pull from Docker Hub every time, right? So to answer your question, one of your question, so when we say from Node, it is pulling the Docker image from Docker Hub, right? So by default, it will pull from Docker Hub. Okay.
Okay.
So step 2 is we are trying to make /my project is the working directory. So that also already completed because it's already in cache, right? Then we are copying add package.json, that is also in cache. Then we are doing npm install. So basically what happened is npm install is failed. So it is saying tsc not found, right? So basically we might have actually broken our so we don't have package.log.json. So it will be created inside the Docker image. So we removed some of the dependencies, right? So we might have so our package.json might be not proper. Okay. So essentially what will happen is so maybe to fix this, it may take time. So let me just explain what will happen. So basically we are downloading image, node image from Docker Hub. Then we are setting working directory as my project. Then we are copying package.json into the Docker image. So when we say dot, it will copy to /my project. Okay. Then we are saying npm install. So we are able to say run npm install. That means npm install command will be executed inside the container.
Okay.
So what it will do is so for each step, it will create a container, it will execute the command, it will create an image after it successfully executed the command. That's what it will do. So so when we say from node, it will download image from Docker Hub, node image from Docker Hub. When we say this, what it will do is it will create a new container, then it will create a new directory called /my project. Then internally it might make some pointer or kind of thing to make /my project as working directory. Then it will create a Docker image, right? So that is what it's saying using cache. That means it will. So it will for step 2, it will use this Docker image. So step 2, we are telling working directory my project. So it says it already has the image. So for step 3, it will use this image. So in step 3, it will add the package.json into the /my project directory. So that is also already in cache, right?
Okay.
So for step 4, it will use this image. In step 4, it will execute npm install. So currently it is failed, but if it is successfully executing, so it will say npm install is successful. Then what else we have? So then we are telling add
tested.
Yeah. So we are adding our source code into the container. So we have a Docker image which has package.json and all the dependencies installed and our source code. So basically we have Docker image with our source code and whatever libraries needed for our source code to run.
Correct.
Right.
Yes.
Yeah. So we got it. So this is also not enough. So we have to do something like this. So we have to say cmd node /my project test.js. So this is what we have to do. So let me quickly show you this. So we don't have to do all this because test.js is nothing but a simple console.log, right? We don't have anything else. So we don't have to actually do npm install at all. So let me create a Docker image. -t React.js practice. That's it. It created a Docker image. So we have the image successfully created now.
Okay.
right? So basically, I should have shown you like simple example like this. Then I should have moved to package design. But anyways, you got it right. So now we have the Docker image. Okay. Now let's run this. Okay. Let's
Okay.
see what we have. So we have these containers, which is in exited state, right? So
Okay.
let's do this. I don't want to I don't want to keep all these images. So if I start keeping images like the containers like this, um, it will suck up my storage space and it's waste, right? So I don't want all this. So let's clean up. So basically, there is a command called Docker container prune. So it will remove everything. So now I don't have anything,
Okay.
right?
Hmm.
So let's run. So now let's run this. Okay. So so what what is the command I executed in Docker build? So I said minus t is the Docker image name and tag. So basically, I only gave Docker image name. I did not give tag. So if you don't give tag, by default it will use the tag as latest.
Okay.
Okay. So for example, if I say 1.0, okay, as tag. So to tell tag, we just have to do like this: Docker image name
Okay.
colon 1.0.
Okay.
Okay. So when I say this, it will now if I see Docker images, so now I have latest as well as 1.0.
1 point. Okay.
But if you see the image ID, both are same because I did not change anything in the Docker file, right?
Okay.
My Docker file is same, right? So
Hmm.
because Docker
So
can
it will.
understand, yeah, Docker can understand the Docker file is same. So why it has to create a new image? It will not again build everything. So it will just identify, okay, this is already there. Just tag it as 1.0. That's it.
Okay, I have a question here. If
Hmm.
you don't give the tag now, again, if you do a build, it will have the same image ID.
Yes.
Okay. Okay.
So for
So how many
example,
times you build also, it will be same.
right. So that is where this Docker catching will come into picture. So now let's
Okay.
add one more line. Let's build again. Okay. Now
Hmm.
let's make it as 2.0.
Okay.
What's going on? See, now you see it took some time because it,
Yes.
yeah. So what it will do is till this point, it will be same. Only this will be different. So this point, it will use the same catch. Only this from step 3, it will create a new container and it will create a new image.
Okay.
So if you see, these two are same.
Yes.
This one is different.
Correct. Okay.
So
Okay. Okay.
now let's run this. Docker run 2.0. Okay,
Okay.
that's it.
Okay.
So now if you see my list of running containers, nothing will be there. It says it exited,
Oh, completed.
right?
Okay.
So that means, so if you say Docker PS, so Docker PS will list of containers running. Docker PS minus A will list all the containers.
Hmm.
So now we see there is a container which is in exited state. And but when we ran, it ran this whatever text we added in console.log.
Okay.
Okay.
Uh,
Hmm.
okay. So this React JS, this image, right?
Hmm.
This image exists only inside the Docker.
Um, yes. So what do you mean? Can you elaborate?
No, my doubt is we have created image ID in this server. We have compiled our JS code and we have executed that. So now we have a image ID. Now how means this is what the deployment is. You are running Docker run.
Yes, that's right. But there are that's what I'm telling. Don't get into don't try to get all the answers straight away.
Okay.
Okay. So
Okay.
so this is basic, right? So basically it should say node, hello, something like that. It's not React.js. It does not have anything basically, right?
Okay.
So 1.0.
So this is how we create a build using Docker and we execute that image. Okay.
That's right. So so Docker run node hello 1.0. Again, it will say same thing. Okay.
Yes.
So there is an important point here, right? So it says it is okay. Let's do this. Then let me do something, and then you can see what I'm doing, and you can try to understand what I'm doing.
Okay.
I'm also not doing everything myself. I'm Googling and copy pasting everything. Okay.
Okay.
Okay. And I just copy pasted this. I did not do anything. Okay. Now I'm going to create. Okay. Okay. You see what's happening now?
Now it is waiting for some.
Yeah. So it's waiting for something, right?
Yes.
So that is the difference between our that is the difference between our previous code and this. Okay. So it is still waiting. So when I say Docker PS, it is saying it's up 29 seconds.
Okay.
Okay. So can you find out what's happening?
Still the container is running.
Yeah, why?
Maybe it is waiting for something, some signal or something.
Okay, can you find out from this code?
No. It is writing some hello world and it is trying to end. Before that, it is
What is
waiting
this?
for
So
create
basically,
server.
see, so you might have. Do you remember how we do imports in Java? Or forget about Java. We basically do include stdio.h, right?
Yes.
In C. So what is that?
It is adding the header files to our program.
Yeah, why we have to do that?
For our for our input and output operations, it used to check that.
So
there only it exists, all the library kind of files exist.
Yeah, so basically we will be calling some functions from our code. For example, printf, right, in C. So the printf function will be there in the actual code for printf will be there in the stdio.h.
Correct.
So that's why we are including that and we are calling printf. So same thing here. What we are doing is we are importing. So this is the syntax to import in node.js.
Okay.
So we are importing a library called http. Okay. Then so that we are storing it in http object. Then we are using that object and calling the function called create server. Okay. So basically we are creating a http server. and
Okay.
we are telling that should listen on port 8080. Okay, and
Okay.
what we are telling here is when a request comes, this create server function takes two parameters, request and response. So when a request comes, this will execute this code. Okay, so that means when a request comes, it will send 200 HTTP response code, and it will send so each HTTP. So for example, let me do this. So we have google.com, right? So when you open google.com, if you see, forget about all these other requests that are all too complicated stuff. Let's focus on the first request. So what it's saying request URL is this, and request method is get, and status code is 200, right? So
Okay.
that means we send a request to google.com with HTTP request get, and we got a response 200. So 200 is basically successful, and we got content type text HTML. Okay. So basically when we send HTTP request to some server, it will basically respond back with basically we are asking for some content, right? So the content will have some content type. It will be HTML, or it will be simple plain text, or it will be JSON. So there are multiple different kind of text, right? Or it will be image, or it might be video, or it might be sound. So each of them are different type, right? So same way here it is telling just reply back with simple plain text.
Okay.
Then we are telling send hello world. Then it's saying response will end. That's it. So this is very simple example, right? So when a request comes, it will send a reply back with these details. So let's hit now. Okay, now our container is running. Let's go inside the container. Okay, because see, 1 second, just give me 1 second. Whatever I'm explaining, this is useful, or you want me to stop or move to a different topic?
No. Please go ahead.
Yeah. So we are telling listen 8080, right? So do you know how to send HTTP request to our own laptop?
Oh, no.
So that is 127.0.0.1. Okay. So that means so basically when you open google.com, where will the request go?
It will go to that server, right?
It will go to the
IP,
server.
it will go, right?
Right. So again, it's a different topic, but so when we say google.com, it is going to some server and it is getting the response back.
Correct.
So same way, now what I am doing, I am running a HTTP server in my laptop. So how do I access that?
We should access through our IP.
That's exactly right. So there is something called our IP. So what is my IP? Where is it? Where is my IP? It is
count.
Yes, here. 192.168.0.5.
Okay.
Also, you can see 127.0.0.1. Okay, let's try to access. So 127.0.0.1 will be there's something called loopback, right? So I'm going to access my laptop. So to remove the complexity of finding IP and accessing that, there is something called localhost.
Okay.
So when I find what is the IP of localhost, is the host name, and when I find what is the IP of localhost, it's 127.0.0.1.
Okay.
So at any point in time, if you want to access your laptop, you don't have to find your laptop IP, you just have to say localhost.
Okay.
So that is what is localhost. HTTP:/localhost. Okay. So when we say HTTP:/localhost, it will hit our laptop and it will connect to the default port 80. Okay.
Mhm.
So do you know about that?
No, you are trying to connect to our IP through port 8080.
That's right. Yeah. But when I don't specify port, what port it will connect?
Maybe default port, is it 8080?
No, default port is 80. That's what I was telling.
Okay.
Default port is 80. Basically, it will connect to curl. Forget about all curl. It's basically this. So the 80, when whatever port I typed, it gone because 80 is the default one. So even if I type 80, it will be browser will remove that.
Okay.
Yeah. So, but our service is running on 8080, right? Where is my service? So my service is running on my HTTP server is running on.
This port.
Sorry.
Okay. No. You gave listen so that it will wait for that port.
Yes. But still, that is not working. Can you tell why?
Not sure.
So because so the 8080, it's not listening on my laptop. It's listening on the container running
Docker.
inside my laptop.
Okay.
Right. So that is the whole advantage of Docker, right? So basically, you will get a container which is completely isolated from your laptop. So whatever activity you are doing inside a container will not affect your laptop.
Okay.
So that is the whole advantage, right? So now Docker PS. Now let's go inside the container. Okay. So this is the command to go inside the container. So we have to say Docker exec. IT is the default syntax. It's so if I have to explain, it will take some more time. But this is the syntax: Docker exec minus IT container name. Then the cell, whatever. For example, if I say bin sleep 5, basically it will connect to this container and it will execute this sleep command, and it will just done. That's it. So when I say sleep 5, it will sleep for 5 seconds. Then it will come out. That's it. Right.
Okay.
So whatever command I'm executing, it will just execute that. For example,
Okay.
it will execute the command.
Okay.
Okay. So when I say bin sh, yes. So what will happen when we basically say sh? It will create a new cell, right? So
Correct.
so we will get a cell inside a container.
Okay.
So the IIT minus IT is related to this bin sh. So to get a proper cell, we have to do this minus IT.
Okay.
Just keep in mind as of now. If you are interested, you can Google about this, and this is something interesting.
Okay.
So we are inside the container, right? Now ls minus l, see what is there. We are inside
Our code is there. Yeah.
my project.
Container.
Yeah.
Okay.
So now you got it, right?
Okay.
So what is there in our code? The same code what we written outside our container and we copied, that is here.
Yes.
Okay. Now let's see ps minus here. What are all the process running? It says only these three.
Okay.
Right. So basically, when you say ps minus ef in your laptop, let me open and show you. In your laptop or in any Linux server, it will show you thousands of processes.
Correct.
See. But if you see inside the container, nothing is there, just three. That is the whole purpose of using container. So we don't. So we will put whatever application needed, whatever needed to run the application. Only that will come inside the container, right?
Okay.
So basically it's running node this. Again, this is coming from this.
Okay.
So we told this, so it executed the command and it's running, right? So it is keep on running because we have
Given listen.
right, we have given listen, so that's why it's keep on running. So if you don't have this code, it will just execute whatever we told and it will come out. Since we told listen, it will just keep on listening. That is the purpose of HTTP server. So for example, so if I'm, for example, if I'm talking to you, you should listen, then only I can talk to you, right? If you are doing something else, I cannot talk to you. So same way, if I'm connecting to HTTP server should be always listen, right?
Yes.
So then only it can respond back. Whenever some request comes, it should listen, then only it can respond back, right? So
yes, correct.
So what we are doing, so we are inside the container. Let's check if we have curl. We don't have curl, so let's install, let's find out what is the OS. So this is Alpha in Linux. Do you know about this Alpha in Linux?
No.
So basically we have CentOS, Ubuntu and all those things, right? So Alpha in Linux is one of the Linux flavor, but this is specifically designed for containers, because this will be very, very lightweight and it will not have all the unnecessary stuff. It will have only very minimal stuff what is needed for the application to run. APK add curl. So like how we do yum install and apt-get install in Alpha Linux, we say APK add. Okay. So now I have curl. Now let's hit HTTP localhost 8080. So now we got a response back.
Okay.
Now let's say minus
now our
V.
container should get completed, right?
No, why? It will still run. Will still run.
No, we have given end also, right? After that creation.
Okay, that's a good question, but this is actually the concept of node.js, how node.js create HTTP server and all those things. But to answer your question, so if you see, we are creating end because that end will only applicable for the particular request.
Okay.
So client is requesting something and server is okay, respond with HTTP 200 and respond with this text. Then you end the connection. Basically, it will close the connection between client and server.
Okay.
That
but
is
then
the end.
our
It's
container
not,
will be running.
yeah, yes. For example, so now let's do something interesting. Okay. Let's hit this. Okay. Yeah, let's hit this multiple times.
Okay.
Not sure if syntax is correct, but let's try. Yeah, syntax is correct. So what I did now is basically you can understand from this, right?
Yeah, yes.
So I'm basically
executed the curl command 10
yeah,
times.
I'm basically requesting 10 HTTP requests, and it's replied with every time it replied with hello world, hello world, hello world. So if I say 100,
yes. So it will keep on listening.
Yeah, so in this example, I'm sending request only from the container. So an actual scenario in production, how it will be like crores of people hitting the server.
Okay.
Crores of people hitting server from different locations. So server should be able to respond, right? So this is my laptop. My laptop is what just only i5 processor and 8 GB RAM. It can handle up to certain request only. So if if we have to handle more users, then we need to have that kind of servers, that kind of load balancing, auto scaling. So that's why all those complexity will come into picture.
Okay.
Right. So what this is doing, this is basically acting as a web server. This is what is the web server.
Okay.
Okay. So what is a web server? Web server is nothing but a server which listens on web request, which is HTTP request, and responds back to user.
Okay. Sorry. One small
Yeah.
question. Maybe it kind of repeated question. The thing is, you executed the HTTP inside the container.
Yes.
Okay.
Yeah. Go ahead. That's what my next topic is actually.
No. How it will come to? Means you created by inside the container. You have your code tested at JS and everything. Your listen was expecting inside the container. So do we means how to bring that outside?
Yeah,
Like
excellent.
now how
Yeah,
you did?
excellent question. I expected you to ask. So let's stop this. That is the next
Okay.
thing, right? So there is no use if we are listening only inside the container, right? So nobody can access it. So let's stop this. Okay. It's not coming out, so we have to do some force kill. Docker ps. So to stop the container, we can say docker stop container id. So it will be slow because this is not a high processing laptop. This is a basic laptop.
Completed.
Yeah. So it's a, so now if you see it came out.
Yeah.
Right. So let's do one thing. So there is something called port forwarding. I think we already discussed about this in separate topic, right? So this is how we have to do. Now run. I stop the container. That container does not exist anymore. Docker run -p 8080:8080, or let's say just to 8081:8080 or 9999, whatever, right? Okay, now it started again. Docker ps. Now you can see something like this. Can you tell me what it is doing now?
No. Whatever the IP they are trying to connect to this port, our normal 8080 port will be listening for that, right?
No.
No. Can you please explain on
Yeah. So what is happening is just a simple concept. So what I am telling is, whenever a request comes to 9999 in my laptop, okay, forward it to 8080 on this container. That's all. You got it?
Okay. So inside container, your whatever the request coming to port 4449, you are forwarding that to port 8080 in the container.
Yeah, that's it. So because our inside the container, my process is running on 8080. Okay. So I need some way, whenever request comes to my laptop, I have to forward it to 8080 on inside the container.
Okay.
So that's what I'm doing. So you can give any port here. Whatever port is free in your laptop, you can give here. That's why I gave you different port. Like
so you will be. Okay, so you will be connecting from your laptop to 9999. That will forward to the containers 8080 port. Okay.
That's exactly right. That's it.
Okay. Fine. Super.
So if I say 8080, it will be listening to 8080, or let's do this, right? So Docker star. Okay, let's do this, right? 80.
Okay, default put.
I don't know why it took this much, why it's taking this much time. It should be fast. Okay, so that's it.
Yes, and we are getting it. Okay.
Yeah. So yeah.
Super.
So yeah, that's it.
Okay, this is how we access our container from outside the
Yes.
container. Okay.
Okay. Now so okay, assume we have so many users. Okay. Okay. Now running only one container is not enough.
Okay.
Okay. I want to run three containers for my same code.
Okay.
So for example, in server, what will happen? You will deploy your code in one server. Okay. When too many users are coming, what you will do? You will add two more servers, right? And you will attach a load balancer in front of them that will forward request to all three of them.
Okay.
Right. Now I want to run. Okay, I'm running. So when I say Docker run, it will basically run in foreground. That means it will connect to my terminal. So if I close the terminal, my process will be stopped. So there is something called -d. So when I say -d, it will run in background.
Okay. Kind of ampersand symbol in Linux.
That's correct. Yes.
Okay.
Yeah. So it will come out, but the container will keep on running.
Okay.
Okay. So now if I say again execute this, it will fail because
Port is already allocated. Okay. Same port is already allocated.
So I have to do something like this. Okay. Now
Okay.
I have this.
Okay.
You got it, right?
Okay. So you have opened 3 ports for your local host, and whatever the port we are connecting, it will connect to the different containers.
So basically,
but same code.
Yeah, same code I'm deploying. So that is the advantage of Docker. So now you have, if you want to deploy 10, if you want to auto scale to 10, you just have to run 10 containers.
Okay.
So if you have to do it in the server, what will happen? You have to create a server, you have to deploy the code.
So my building the my building the code, and I'm creating one image. On that image, I can run how many containers also.
Yes.
I mean, when I'm running, it will create a container, right? So same that build file, I'm running so many containers.
You are using the same Docker image, and see, you already packaged your application into Docker image. So you have the production ready Docker image. So if you want to run 10 or 100 or 1000, it's up to you. You just have to create that many containers.
Okay. And whenever we are creating a new container, it should listen to separate port, or is that
right? So that is a challenge now. Okay. Yes. So that is the next step. So what will happen? So how the user will connect? So they have to do this, or they have to do this, or they have to do this, right?
Yes.
But I don't want to tell customer, okay, now you access this, now you access that. That is not possible, right? So I want to give single URL. So when user access that, in the backend, it should load balance between all these three.
Correct.
That is where load balancer will come into picture. That is the job of load balancer. So in load balancer, what we will tell, just connect to all these three, right?
Okay.
So load balancer will have its own host name. Maybe it may be localhost 84. Or what you have to do is you have to listen on 81, 82, 83, and in load balancer you have to use default port.
Okay, so whenever they hit that load balancer, it will go
in the backend
to all three.
Okay, let's do that, right? So you, or not sure if we can do that with Nginx. Do you know about Nginx?
No, it is
You know about Apache?
Web server.
Yeah, Apache is one of the web server, and Nginx is another web server. There are so many web servers available. So Nginx is the famous one. So for example, okay, this is a complicated code. Okay, so let's do this, right? This is complex, but let's do this so that we'll get some good hands-on, right? So okay. So you want me to do this, or you want me to explain something else?
No. Please go ahead with this. I will try to understand.
So let's create a directory for Nginx. Copy this code. So what they are telling, okay.
Normally, sorry to interrupt. Normally, means I have created a DNS kind of like I will give the first server IP, second server IP, and the listening port in all the servers. Like I will run a service on that all servers, and whenever that service is up, that port is up, so that we will connect through the DNS. That is how we have configured. So when user hit the same URL, it will connect to the port, whichever server is available. It will connect to that server. That is
that's
how
that's what we are doing.
Okay.
So what?
That concept, I'm aware. Like
the same thing. If you see here, you can see, right?
That this is what this kind of thing only we have done it. Whenever which server is available, it will connect to that.
Now we are going to do the same with container. That's all.
Okay.
So what they are telling, whenever a request comes to /, it will forward to HTTP load balancer. So they are creating something called load balancer here itself, and they are adding two different servers.
Okay.
And they are telling weight equal to 6, weight equal to 4. That means 60% of the request goes to app 1, 40% of the request goes to app 2.
Okay. This is what the containers you have created. Three kind of containers they have given inside this server. Okay.
But I have a challenge now. Even I don't know how to do this. Let's try. 82.
Connecting to localhost, right?
Yeah, that's what even I'm wondering how to do this. Because how does one container can connect to another container? That is the challenge now. Right.
Confused. How means we have created three containers with three different port.
Right. See, So I'm going to run this Nginx as a separate container. Okay, and I'm going to run our application into 3 different containers in 81, 82, 83. So total, I will have 4 different containers.
Okay.
Right. So every request will come to Nginx container, then it will load balance to all other 3 containers.
Okay.
Right. But since what is the IP I will give here? So that's what I'm trying to find out. Let's see. Okay, they are telling we can do this with Docker. Create 2 containers. Yeah, okay. Then create a new network. Okay, they are telling we have to create something called network. Okay. So once we create a network, we have to add these 2 containers into this network.
Okay.
Okay. Then we can connect. That's what they are telling. So okay, let's try this. Okay. So maybe it should be possible like this. So you don't have to do all complexities.
Okay.
Okay. So Docker, let's see. First, let me stop everything. Docker stop. So okay. So let's create Docker network, create my app. Okay. Create it. Now run 3 different containers, right? Docker run. So let's remove this. I think we don't need this. I will tell you why. Okay. Sorry. So I have to give a name. Docker run minus name as 1. Name as 2. Now if I say Docker PS, I have app 1 up to app 3 running, right?
Okay.
Okay. Now so I have nginx.conf, which says, okay, first before that, let's Docker network. Yes. Okay. I have a network called my app. See, we have already different networks. So Docker network connect my app into app 1, app 2. So I'm adding app 1 up to app 3, all of them into this network, my app network.
Okay.
Okay. So now I have Nginx. So now total containers I have 3 containers running for my application.
Okay.
Okay. Now Nginx. Let's build this Nginx. So they have to create Docker file from Nginx.
Okay.
So Nginx is a web server. We are just going to, there is an image already. We are going to download the image, run the image, and create a container. But before doing that, we are going to just change the configuration file. That's it.
Okay.
So let's take Alpine. Where is Alpine? Should be colon Alpine. So it will pull the latest. So instead of taking latest, we can always say 19. So this is how we have to run in production. We should not take latest into production because the latest tag will be keep on updating. Right. So for example, if I am deploying latest image today and after 1 month I'm restarting the container in production, it will again pull the latest from Docker Hub. Then it will become a problem. We don't know what exactly is running in the tag.
Okay.
To add, where is the config file? It will be etc nginx.com. Okay, let's do this. So we don't have to do all this, right? There is a different way of doing this. So instead of creating a Docker image and running that, so we don't need a Docker file at all. So let's do this. .19. So they are telling so do you see what I'm doing here?
You are trying to use the config file in your server.
Let's call it as Nginx. So now I need to say -p. Okay. So this image is not there in my laptop, so it will pull from Docker Hub. So do you see what it is doing here?
The request you are getting.
No, it's
no,
not about
it is actually it is the Nginx web server installed in your machine, right?
No, I don't have it installed in my laptop. I'm just running the Docker container, Nginx container. So what I'm doing is, so -v is a volume. Okay.
Okay.
So inside the container, I want to change the configuration file, right? So one way is to create a Docker file and copy this Nginx configuration into the container and create an image and run that image. Other way is this.
Instead
Right.
of
So
using Docker file, you can give here directly.
Yeah. So what it will do is it will. So while running the container, it will mount this file from my laptop. Same way how we are telling port forward. Whenever request comes to 80 in my laptop, forward it to this. Same way, it will mount this file in my laptop into this file in the container.
Okay.
And run. So you don't have to create an image. This is a cleaner way of doing this, right? So you don't have to create a new image for example, you might be having so different kinds of application in your project. So one project might use this configuration, another project might use different configuration. So you don't have to create different images for each project. So image will be same, only change will be config file.
Config file. Okay.
Yeah. So and this RO is read only. So inside the
Okay.
container, you cannot edit the file. So it will be mounted as a read only. So let's see if it is running. Okay, it is not running. Why? See Docker logs in the container ID. Okay, upstream directive is not allowed here. Okay. We are only telling this, right? Maybe you have to copy like this. So let's mount it to this file as well. So it is telling there is a container with Nginx already there, so I'm removing it.
Okay.
Okay, now it is running. Okay, so it's saying it is not able to find app one, so we cannot run it and mount it. The only way is to while running itself, we have to
Create a
specify
Docker
that.
file.
No, while running itself, we have to specify the network. See, it is saying it is not able to find app one.
Okay.
Because
so you now URL is ready and it is not finding the app one container.
yes. So we have to while starting the container itself. Okay, minus network. So it's strings. So even I will never tried all this because I will tell you why I never tried all this. Don't scold me after you. After I tell you that. But this is fundamentals, right? So we should know this. So when you understand this, you can do anything. Again, it's so it's let's see if it is running. So
yes, it is up.
It's up. So it is running. Okay, ready for startup. Configuration complete. So it is running. So let's try to access. Using on port 80. So let's try this.
Give load balancer or something upstream.
Okay.
Okay.
It's working. So basically what it is doing is, okay, now let's do something. Let's stop again. Just 2 minutes, I will do one thing. So that we are clear what we are doing.
Okay.
So our setup is already working, but just to make it more clear, I'm doing this. So let's create 3 different images, right? So it will be hello world from container 1.
Okay.
Docker view 1. Let's just name it as 1. Wait a second. 2. right? Now I have three different images: Docker
Okay.
run -id -d. What is the container name? Sorry, image name. Okay, node HTTP server. Docker run HTTP server :1 minus name. App1.
Okay.
Two and app2. 3 and app3. Do we still have our Nginx running? Yeah, we have still.
Yes.
So what will happen now? Okay, it's not working. Can you find out why?
We have not added these containers to our network.
Yes, exactly correct. So connect. So basically, while running itself, we can specify the network name. We don't have to do. I don't have to connect it separately.
Okay.
Okay. Now let's hit this.
It came already. Okay.
See, it's changing, right?
Okay. Yes. Excellent.
It's coming from 1, it's coming from 3, it's coming from 2. So every time it will go to new because we gave weight as 111. So we can give how much we want to give, right?
Excellent.
So that is what it is, right? So so you got it, right?
Yeah, on small, just for clarification. So we have created 3 different set of code to identify. We have created 3 different set of code and 3 different containers, and we have created a image for the Nginx web server.
Nginx.
And then we have created a network to add all these containers. And then what you have done is you have run which container you have started? You have started the Nginx container.
So we have 4 different container running.
Correct.
One for load balancer, which is Nginx, and all 3 are our application. All other 3 are our application. So, so if we see the Nginx configuration, here we are telling whenever a request comes, forward it to this. So that is again nothing but a
function. Okay.
Yeah. So this is the Nginx syntax, right? So, so we don't have to worry much about this, but yeah, it is Nginx configuration which tells whenever a request comes to forward it to this host, and we are inside Nginx itself, we are creating a host. So Nginx provides a way to do that. So inside that we are telling forward it to all 3.
Okay. Here you have mentioned app1, app2, app3 is nothing but the containers.
So yeah, so that is nothing but the container name.
Okay.
This name.
Okay.
So what is happening is this is the future of Docker, right? So when we create a network and add the container to the network, so what happens is so all these 4 containers are part of same network, right? So that means from any one of the container, if I try to access a server called Nginx, it will be forwarded to this container. The request will forward to this container. So when I try to connect to app1 from any one of the container, the request will forward it to this container.
Okay.
Yeah.
So even if are in different containers, app1, app2, app3, if we give different listen port, we have to specify in the load balancer function.
That's exactly correct.
Okay.
So here also you can see only for Nginx container we are giving port forward. We are not giving for this.
Yes.
So how do you understand how that works?
Because it tries to connect, because this all three in the same network, right? So it will search for the port
Yes, that's correct.
8080.
Yeah. So when a request comes to Nginx from laptop, it is forwarded to Nginx container. So Nginx container is forwarding the request to app one, then getting the response back, then it is sending the response back to the user. Okay, so this is something called reverse proxy. Have you heard about reverse proxy?
No.
Yeah, this is what is the reverse proxy. So basically the load balancer is nothing but a load balancer is a reverse proxy.
Okay.
That means so proxy, you know about proxy, right? Proxy is what you handle the request for some other server, right? So that is proxy. Right. So with proxy, what will happen is, for example, we have user, and we have a proxy server, and we have application server. Okay. With simple proxy, what will happen is when user connects to proxy, the request will be forwarded to the application server, and application server will respond back to the user directly. Right. So that is proxy. With reverse proxy, what will happen is the user will not have any idea about what is running in the backend.
Okay.
So the user have no idea about finding out what is the server in the backend. So for example, if I say, so this is the request, and you can see that in the response header, you can see server is Nginx. But actually in the backend, we are running node.js.
Correct.
Right.
Okay.
So Nginx will hide the details. So that is what the reverse proxy is.
Okay.
So the user will not know what is running in the backend. So it might be a Java HTTP server, it might be a Python HTTP server, or it might be any other server, or it might be anything else. So everything will be abstracted in reverse proxy. So that is the concept of reverse proxy.
Okay.
Any other question? So that is, so again, this is the port number 8080, right? So that is the whole idea of using Docker, right? So you don't have to so basically we change the code just to understand
which container it is
the
executing.
request is going. In actual scenario, you don't have to change anything in the code. You can listen on the same port, because this is a completely isolated container. It will have its own set of ports.
Okay.
So if you see in the complete exercise what we have done, everything is running inside the container. We don't have anything running in my laptop.
Correct.
So now I can delete this Nginx file. Now I can delete everything I have in local. Right. Now I don't need all this. I don't have the code of what is being running, right? But the application is still running. So that is what will happen in actual scenario, right? You will build and create an image from one server, generally from Jenkins server, and keep the image in Docker Hub or ECR Docker repository. Then you will push the container to production server.
Okay.
Production server will have only the container, and it will not have anything else.
Okay.
So in this scenario, again, one more point is, this is web server, this is application server.
Okay.
So application server is the one basically handles the business logic. That means it will connect to database, it will connect to whatever backend service like Kafka or Elasticsearch or whatever. But in the front end, everything will be, all the traffic will be handled via load balancer or web server.
Okay.
So again, yes, so you don't have to expose all the server to internet. You just have to expose the web server to internet, or the load balancer to internet. That is the job of load balancer or web server.
Okay.
So I was telling about I never done all this method create in container, right? So the reason for that is everything, all these features what we are doing now, we can do it in Kubernetes.
Okay.
Right. So you don't have to do all this how to say, you don't have to create new network, you don't have to create all these things. But again, yes, you have to do all this in Kubernetes, but it's a different so it will not be like Docker network create. It will be a different command and different naming convention with different feature, but the concept will be same.
Okay.
Yeah, so you can do it in Kubernetes, or you can do it in there is something called Docker Swarm, that is again Docker container orchestrator. So you can do it in Docker Swarm, or you can do it in, even you can do it in Docker Compose.
Okay, I think we are too early for that.
Yeah, but still, yeah. Now I think if you see Docker Compose, you can understand what is Docker Compose. So where is the Docker Compose? Just trying to find out the simple files. Okay, so this is one of the Docker Compose files, right? So if you see here, what we have actually three different, we are specifying three different sections. So basically it will create three different containers. So in Docker Compose file, it is called services. Okay, so we are creating one web server basically, right? And we are creating one Redis server. That means we are creating one web container, and we are creating one Redis container, and we are creating one Datadog container. Okay, and we are telling link, right? So so you see, ensures that Redis is a host that the container can find. So that means from Datadog, when you connect to a server called Redis, it will connect to this server.
That container. Okay.
Yes, and from web, when you connect to a server called Redis, it will connect to this server. And from Datadog, when you connect to a server called web, it will connect to this web container. Okay. So so what is the purpose of Docker Compose is, so whatever we have done now, right? So now I have all these things. I have 4 containers running. I have created an image and all those things. Okay. Now I want to run the same thing in production. Okay. Now how we will do this?
So we will be creating 3 different kind of Docker files, right?
Yes. Then we have to create three different network. We have to run. Say we have to execute Docker run. So basically, whatever we have done till now, we have to again repeat the same thing in production server. Okay. So instead of that, we can use Docker Compose, and we can put everything in a file. That's it. So what you have to do is, we just have to install Docker Compose in production server, and we just have to say Docker Compose up. Then it will, whatever we did, whatever commands we executed manually, Docker Compose will execute in the background, and it will try to bring up all the containers. That's it.
Okay.
Instead of we doing it manually, Docker Compose will do it for us. So only thing is, you just have to create this file.
Okay.
The advantage is
no. Sorry. You created this file. You have to execute this compose file, or
yes. So we have to see again. This is Docker Compose is some tool, right? Some software. So what Docker Compose will do? It will just, whatever commands we executed manually, it will execute automatically using this command. Yeah, using this YAML file. So Docker Compose understand this YAML file. So when we say link Redis, it knows what command to execute in the background.
Okay.
So that logic or that code or that intelligence is written into Docker Compose tool, Docker Compose software. So we have to install the Docker Compose software in production. Then we have to copy this file, YAML file into production, we have to say Docker compose up, like Vagrant up, we have to say Docker compose up. It will start all these 3 containers with all these port forwarding, with all these volumes connected, with all this network created, with all these environment variables. It will bring up the container.
Okay.
Yeah. So the advantage is you just have to write this file only once. Whenever a new person joins your team, you can just share this file to the new member. He just have to say Docker compose up. You don't have to execute all this Docker run network, all this man.
Okay.
You don't basically you don't have to know about all these things. You just have to install Docker compose up. That's it. So that is the difference between DevOps and developer, right? So DevOps people will be doing all this, and we will help developers to bring up the application how much fast they can. So basically, Docker compose will be used for development in local, and in production, Kubernetes will be used.
Okay.
Right. So let me give you another one simple advantage of using Kubernetes, right? So now we have done all this, right? Now I want to say, for example, I want to run this in 3 different servers. For example, assume I'm running this now in my laptop. Okay, I'm running 3. Okay, for example, so I'm running out of my CPU and memory limit in my laptop. Okay, I want to add 3 more containers. Okay, 3 containers is not enough for me. I want to run 6 containers for my user to successfully access my application, because so many users are coming now. I want to increase 3 more containers. Okay, what I have to do, I have to increase to 6 containers, I need more computing and memory power, right? So from where I will get, I cannot run everything in my laptop. I have to add 1 more server to the cluster. So that is what cluster is. So basically, I will have 2 different laptops, right? One laptop will run 3 containers, another laptop will run another 3 containers.
Okay. So which cluster is up, it will connect to that.
There will be only one cluster. In one cluster, there will be 2 different servers.
So both servers will be available for connecting.
Yes.
Okay.
Because assume, for example, so how to say, okay, let's, if I draw a diagram, it will be helpful. But do you want to continue or you want to stop?
Okay, let's finish with this topic.
Okay. So
the reason I am getting confused is my understanding of DNS configurations is like we have 2 servers. One is a production server, one is HA server. So whenever the production server goes down, we try to connect to the HA server.
I'm not getting I'm not getting into HA at all now.
Okay. Maybe
so let me so how this will work in production, I will tell you so you can understand. So for example, so this is server 1. Okay, server 1, I have I have 3 containers.
Okay.
For example, my server 1 have 3 CPU and 9 GB RAM. Okay.
Okay.
Now I'm giving 1 CPU, 1 GB RAM. 1 CPU, 1 GB RAM. Okay. Should be 3 GB RAM. One CPU, 3 GB RAM. Okay.
Okay.
Now, for example, I'm having thousands of users. Okay. Now they are able to access my. Let's assume this is 10 GB. Okay.
Okay.
Okay. Now Nginx will be handling traffic for all 3 containers. Thousands of users are able to access the application properly. Now, now application become famous, so another 1,000 users are using the application. Now I want to increase the number of server to handle the request. So how do we do this? One way is to change 10 GB to 20 GB and change 4 CPU to 8 GPU and add 6 containers into same node.
Yes. Okay.
Right. That is one way. Another way is create one more server with same configuration. And we have to point Nginx to so we don't need 2 Nginx, we just need only 1 Nginx. We have to point Nginx to forward traffic to all 6.
Okay.
Okay. The thing is, we cannot do this with Docker. We cannot do this only with Docker. So Docker can understand only one server. It cannot understand cluster, right? So that is why we have to use Kubernetes.
Okay.
There might be ways Docker can do that, but so you may have to create all sorts of like Kubernetes is designed for that, right? So if you use Kubernetes, you can do all this. If you want to do it plain Docker, whatever Kubernetes is doing, you have to do it manually.
Okay.
Right. So why you have to do everything manually? If already there is a open source tool which is free and you can use it. So that is why Kubernetes is famous. So so Kubernetes can do this. So what you have to do is you have to add one more to your Kubernetes cluster and you have to increase the container count to 6 and you have to point your Nginx to connect to all this.
Okay. So that Nginx will have the weightage of connecting to the containers.
Yes, but actually in Kubernetes you don't have to do that again. So Kubernetes itself have the okay. Let me but if I'm
I'm sorry.
No problem.
No.
Correct. Whatever you're asking is correct. So in Kubernetes there is something called service. Okay. So what we have to do is in Kubernetes we have to create the service. App service. Okay. So now my cluster is all this is my cluster. Okay. So it will be like this. So the service will connect to all six containers. Okay. In Nginx, what you have to do? In Nginx, what we have to do is we just have to say connect to app service. That's it.
Okay.
Okay. So again, if you go in, if you go one step further into Kubernetes, basically we don't need this at all. We don't need this Nginx at all. Okay. There is
then
something.
How will the users connect?
There is something called Ingress in Kubernetes.
Okay. This will act like a web server.
Not act like a web server. That is a web server only.
Okay.
So basically,
okay.
so you don't have to
Okay.
deploy Nginx yourself. Basically, Kubernetes will take care for you. So what we have to do is we just have to deploy Ingress. Okay. So again, if I go deeper, it's so let me tell you this so you can understand the complexity of cloud and all this, right? So basically, there is something called Ingress Controller in Kubernetes. Okay. So
Okay.
when you create an Ingress, when you deploy Ingress Controller, it will deploy the Nginx container for you. You don't have to deploy it. So basically, it will do the same thing what we are doing, but it knows how to do it. And whatever configuration we are doing right here, I deleted the file. So whatever configuration we are doing here, right? So this configuration we have to do it in Ingress.
Okay.
So so you don't have to create a config file, and you don't have to create a Docker image. You don't have to deploy. So you just have to tell the configuration to Nginx. Nginx will manage all that for you.
Okay.
Okay. So that is how it works in Kubernetes. So if you go one more step further, so what will happen in AWS, right? So there is something called, so basically the Ingress is by default it's called Ingress Controller. In AWS there is something called ALP Ingress Controller. Okay. So what that will do is when you create a ALB Ingress Controller in a Kubernetes cluster which is running in AWS, it will create a load balancer for you.
Okay.
Right. It will create a load balancer for you. Even this is little advanced topic, and this is very new topic. Many people might not know about this. So, but let me tell you, because this is how the complexity is. So when you create an Ingress resource in Kubernetes, it will create a load balancer for you. That load balancer point to all these containers.
Okay, it will.
You don't have to have all this.
No app service. Okay.
Basically, we have to have this. So basically, it will be. It will be load balancer will connect to this service.
Okay.
It will be like this.
Okay.
But the thing is, you are avoiding. How to say? You are avoiding. So if you don't have this load balancer, what will happen? You will have Nginx running here, right? So whatever request comes, it will come inside the Nginx, and Nginx should forward all the requests to the application.
Yes.
Right. So, but here we are using just a load balancer, so we can manage all the configuration in load balancer itself.
Okay.
So there are, yes, it will be like little confusing, but yeah. So that is how the complexity is. So we have to discuss more to understand deeply.
Okay.
So that is how it is. So now coming to your HA question, right? So what will happen in AWS? Generally in AWS there is something called availability zone.
Yes, correct.
Okay, so this will run in availability zone A, and this will run in availability zone B. Okay, so even if availability zone B completely goes down, our application will be running in availability zone A.
Okay.
Okay, but there is something called disaster recovery. This setup does not cover disaster recovery. So disaster recovery will come when so there is something called region in AWS. Okay, yes. So region is availability zone A, availability zone B. Both of them will come into single region.
Okay.
For example, AP South 1. AP South 1 is in Mumbai. Okay, that will have 3 different availability zones. Availability zone A, B, C. Okay.
Correct.
And AP South Zone is the region.
Yes.
Okay. So what we have to do is we have to have the complete setup here and the complete setup in AP South 2. I don't know if AP South 2 is there or what is it called? I don't know. There is something. There is a data center in Chennai.
Okay.
Okay. So we have to run the complete stuff again in AP South 2.
Okay.
Right. Then we have to have some way that forwards the request to AP South 2 if AP South 1 goes down.
Okay.
Right. That sum is, again, it will take more time to discuss. But
Okay.
see, basically, most companies will not have this.
Okay.
They will have only this. And what they will have is, they will have, since everything is Docker container, we have the image ready, we have the configuration. Basically, we have to have this service configuration, container deployment configuration, ALB configuration. So everything will be in YAML file, which will be in Git. Okay. And the cluster creation, everything will be in Terraform. So when something happens, what generally people do is, because this disaster recovery happens like, I don't know, it will happen once in 5 years or once in 10 years. Right.
Okay.
So yeah, but it's very important to have, we don't know when it will happen. It's very important to have this backup plan, right? So everything will be automated in Terraform or CloudFormation, and you will be having all the YAML file. So when something happens, you have to execute the automation script that will bring up your cluster in 30 minutes or 1 hour.
Okay.
The main complexity will come from how the database will have the data in both the zones. Right. So that is not simple. People will ask in interviews, just tell this is very simple. This is very simple, but this is not at all very simple. Database replication between different regions is very, very complex.
Okay.
So we have to have some, but again, we can do it, but it's not simple, it's complex. So we have to have a plan, we have to have the proper setup in place to have the replication from one region to another region. But so we don't have to go that much deeper initially, right? So we have to understand first this cross zone deployment, then we can move to cross region backup plan. So any questions?
No, as I mean, there are the end topic. It has more questions like what is Terraform and
that that is a different topic, right? In this topic, you have any question?
No.
Okay.
Thank you so much.
Okay. So yes, so that's about Docker, high level of Kubernetes and all this. Let me stop recording.